you have got a clear idea about what is what and what is going. Okay. So in this particular session, we will start with the AHB master interface signals. So what are the interface signals actually this particular master is going to have, that we are going to see them briefly. Okay. So let me share my screen quickly. Please confirm me whether my screen is also visible so that we can start quickly. Yes, thank you. So yes. So in this particular session, we are going to start with our manager, which is also known as your master. Okay. So this particular master, this will have some specific interface signals. Okay. So these particular signals are very important actually. If you want to understand the protocol working clearly, you should have some pretty knowledge about this particular signals. Okay. So coming to the global signals, these are your global signals which are shared between the master and slave. These are your reset signal and clock signal. So this particular AHB protocol is a synchronous protocol. It is a synchronous protocol. So can anyone tell me what is meant by synchronous? What is meant by this term synchronous? Any idea? What do you mean by this particular term synchronous? Anyone has any idea about this? What do you mean by the term synchronous? Any idea? Anyone? No one? No idea? Anyone? Any idea? If you know already, what do you mean by synchronous?
Same clock will be applied.
Yes. So the master and slave will share the same clock. Okay. So both the master and slave are synchronous to each other. Okay. So the master and slave are synchronous to each other. So yes, master and slave work on the same clock. Okay. So AHB protocol is a synchronous protocol. Not only AHB, APB, AXI, everything. These are all synchronous protocols. Okay. So here the data transmission will be synchronous to each other. Okay. So that's why if you can see this, this is your global signals. That is your H clock and H reset in is given to your master and slave. And one more thing, if you observe that signals here, your signals are denoted with the letter H. Okay, so if you see here, your signals are denoted with the letter H. So this notation is to indicate that the signals are related to AHB protocol. Okay, so here the letter H indicates that it is of AHB protocol, and in ABB protocol you will have the signals represented with P. Okay, so like P clock and P enable, like that. So in AHB protocol you have the signals H, and in APB protocol you have the signals P. Okay, so keep this in mind. So everywhere in AHB protocol specification, you will have the signals which are denoted with the letter H in the starting position. Okay. So coming to this H clock and H reset N, it is an active low signal. Okay. So that's why it is noted with the small n. Okay. So this is your active low signal. Okay. And this H clock and yeah. Yeah. So what do you mean by active low and active high? Quickly, does anyone know this? What is meant by active low and active high? Any idea? Anyone? What do you mean by active low signal? What does it actually tell? Anyone? Any idea? Quickly. What do you mean by active low signal? No idea. No one. What is meant by active low signal? Hello, is my voice audible? What do you mean by active low signal? Okay. So this active low signal means it in my voice is audible, right? Am I audible, right? Yeah. That means if you apply the yeah, that means if you apply the zero, it will be activated. Okay. And in the case of active high reset, yeah. And in the case of active high signal, if you apply one, it will be activated. Okay. Yes. So these are your two signals. These are your global signals. Now, And one more thing, you have two signals which are known as transfer response signals. So let's say this is your master. Okay. So let's say this is your master and this is your slave. This is your master and this is your slave. Let's say master wants to perform some write operation. So in the case of write operation, the data flow is from master to slave. Remember this, in the case of write operation, the data flow is from master to slave. And in the case of read operation, the data flow is from slave to master. Okay, so please remember these two directions. In the case of write operation, the data flow is from master to slave, and in the case of read operation, the data flow is from slave to master. Okay, now let us consider we are performing a write operation. Now let us consider we are performing a write operation. So in the write operation, let's say master is sending some random data to the slave. Okay, let us assume, let us now don't care about how the master is sending the data, which bus it is going to use, what is the size of the data, okay, vagara, vagara. We are not focusing on that. Just we are considering that master is sending some data in the case of write operation from master to slave. Okay, and how the master is going to send the data to the slave, whether it is going to send the data to the slave as it is at a time, like whether it is going to send it randomly, or should there be any condition, whether master can send data to the slave at a time or some without checking anything, or should it check for anything, or should there be any constraint? Any idea, anyone? What do you think? Can master send the data as it is, or should it check for something, or should there be any constraint? Anyone, any idea? Anyone wants to answer this? General speaking, I'm speaking very generally, not about regarding this particular protocol. I'm speaking very generally. So, master, can it send the data as it is, or should it check something, or should there be any constraint without before sending the data? Okay, address of the slave should be known. Okay, very good. Next, address of the slave should be known. Okay, next. Anyone wants to answer? Should there be any constraints, like what should be the constraints before the master sends the data? Okay, valid data. Okay, okay. I will give you one simple example. Okay, I will talk very generally, not in the terms of this particular protocol. I will talk very generally. Let's say if I want to conduct the class at this particular protocol class at 7:30. So what I'm doing, I'm texting the message. I'm posting the message in the group around half an hour before. Like the class will be at 7:30. Okay, at 7 p.m. I'm texting in the group that the class will be at 7:30. So what I'm telling actually, what I'm doing actually here, I'm basically informing the thing. Okay, I'm basically informing the thing that be ready for that particular class. Or what I'm doing actually is I'm asking whether you are okay with this. Okay, actually not. I'm not asking with that. So actually, what I'm asking, please be ready for this particular class. Okay, so the master here, it will do the same thing. So the master is checking for the slave is ready or not. Okay, so before starting any transaction here, the master is basically checking whether the slave is ready or not. The master, as it is, it cannot send the data or it cannot read the data. It should check whether the slave is ready or not. Is this point clear or not? Yes or no? Please let me know. So the master, it should check whether the slave is ready for the transfer or not. It may be write transfer or read transfer. It may be anything. Yes. Okay. It may be anything. It may be write transfer or read transfer. So I want participation from everyone. It should be a full duplex session. Okay. So everyone, please try to respond. Then only I can know whether you are following me or not. Because it's an online session, I cannot see your faces and I cannot judge. Yes, I will come to that. Okay. Uh, so please try to be interactive. So because it's an online session, I cannot see your faces and I cannot judge you whether you are able to understand or not. The main motive of this particular workshop is to get you understand about the protocol. So please be interactive. Yes, what is meant by slave is ready? Let's say if the master wants to read some data from the slave. Okay, let's say if master wants to read some data from the slave. Okay, the master wants to perform the read operation from the slave, but slave is internally doing some another operation, and it cannot send the data to the master in the read operation. If we consider a read operation, the slave is sending the data to the master. The master is requesting the slave to give me the data. Master is asking the slave to give me the data, but slave is busy performing some other operations. It cannot give the data. It is busy with some other work. So it is not ready for the transaction. It is not ready for which transaction? It is not ready for read transaction. Okay. Is this clear? Is this clear? Yes. Okay. So that is meant by slave is not ready. Slave is busy. Okay. What is meant by slave is ready? You have asked, right? So that is meant by slave is ready. Okay. So if the slave is ready, then only it can give the data in the read operation. It can give the data to the master, or else how it can give. Okay. So before starting any transaction, it may be a write transaction or a read transaction. The master checks whether the slave is ready for the transaction or not. That is very important. Okay. So if the slave is not ready for the transaction, how the master will communicate with the slave? No, right? Okay. So this is how there is one signal which is known as H ready signal. Okay. So if you observe this direction of this arrow mark, it is input to your manager or your master. Okay. You can say it to your manager or your master, anything. So if you see the direction of this particular arrow mark, this is input to your master, and this particular signal is given by your slave. This particular signal is given by your slave. So the slave is sending this particular H ready signal, indicating that it is ready for the transaction or it is not ready for the transaction. Then only master will come to know that whether the slave is ready for the communication or not ready for the communication. Is this clear? The H ready, is it clear? H ready signal, is it clear? Okay. Should I go slowly? Is my pace too fast? Is my pace too fast, or is it okay for everyone? Or should I go slowly? Okay. So, okay, okay. Okay. I will go slowly only. Okay. Yeah. So I think H ready signal, is it clear, right? So basically, this particular H ready signal is used to tell the master is used to indicate the master that your slave is ready for the communication, whether it may be write transaction or read transaction. The slave uh, uses this particular H ready signal to tell the master whether it is ready for the transaction or not ready for the transaction. So that master will accordingly adjust with itself, that we are going to see in our upcoming sessions. Now, is this particular H ready signal clear for everyone? Is there any doubt in this particular H ready signal? Please let me know. So this signal is very, very important. Please let me know. Is it clear for everyone? Yeah, I got only three responses or four responses, I think. What about others? Is it clear? Or shall I explain it one more time? Yes. Okay. Now, yes. So this is the about the H ready signal. Okay. So, after master receiving this particular H ready signal from the slave, okay, after master receiving the H ready signal from the slave, so there will be a lot of processing happening. There will be address phase, data phase that we will discuss in our upcoming sessions. Okay. So after everything, the master completing its address, data, vagara, vagara, it will complete it. That we will see how it is going to send everything we are going to see. Then after that, the let's say it is a write operation. Okay, let's say it is a write operation. The master will send the address and corresponding data, everything it will send. And after receiving everything, the master should know, right? So it should know whether the transaction has been successful or not. Yes or no? So if I'm delivering this particular lecture, how I can know whether you can able to understand or not? With your response. Okay, with your response in the chat box, then only I can able to know, or whether I can able to get a feedback how I'm dealing with you. Okay, so whether you are understanding or not, or whether I'm going a little bit fast or little bit slow, or is it confusing. So according to your response, I will get to know what is happening actually. Okay, so here the master will also come to know whether the data transfer is successful or not. Okay, with a signal which is known as H response signal, which is known as H response signal. So this signal is used to indicate whether the slave, whether the transaction has been successfully completed or not. Okay, whether the transaction has been successfully completed or not. So this particular signal will help you to understand. So the H ready signal and H response signals, are they clear? Is there any doubt? Are they clear? Yes. Okay. Yes. Now, coming to one more signal, which is known as HR data. Okay, and the widths of the signal also, there are this is actually 2 bits width, this is also 2 bits width. The width of the signal we will discuss in our upcoming session. Just focus on the behavior of this particular signal. Don't worry about the size of this particular signal, width of the signal. What if the particular value is 0001, everything we will discuss. Okay, just in this particular session we are focusing on what is this particular signal is actually the work of that particular signal. Okay, now coming to this HR data, it is of 32 bits width. This is of 32 bits width. Now, so this HR data, this HR data stands for read data bus. So there are actually two data buses available in AHB protocol. So let's say this is our master and this is our slave. So let's say if we are performing write operation, that is the data is being passed from master to slave. So we will use a bus which is known as HW data bus. For write operation, we are going to use this particular bus which is known as HW data bus. Okay. And for read operation, we are going to use a bus which is known as HR data bus. That is for read operation, we are going to use this bus. And for write operation, we are going to use HW data bus. And for read operation, we are going to use this HR data bus. This is also of 32 bits. Okay, so if you want to perform any write operation, then you are going to use this particular bus which is known as HW data bus, and for read operation you are going to use this bus which is known as HR data bus. Okay, the data in the write operation, the data is sent using the HW data bus, and in the read operation the data is received from the bus which is known as HR data bus. Okay, the HW data bus and HR data bus, are they clear? Anyone, any doubts up to here? So we have completed this HR databus and HW databus. Are they clear? Yes. And if you see the directions also, please focus on the directions also. This HR databus is input to your manager. This is coming from your slave. This is coming from your slave module. So this HR databus is input to your master and this is output to your master. And this HW databus is output to your master. This is please observe the arrow marks here. This is output to your master and input to your slave. Okay. Yes, I hope this HW databus and HR databus are clear. Now, coming to one more signal, which is known as HADDR, which is known as address bus. Now, so in AHP protocol, what is going to happen is, so let's say we are performing some write operation. Let's say we are performing some write operation. Okay. Let's say this is our master and this is our slave. Okay. So we are going to use our HW data bus. Okay, well and good. Now, so can anyone tell me why we are going to use this particular address? Why we need this particular address? What is the use of this particular address? We are simply sending the data. It's good and enough, right? Why we need address? Any answer? To identify which RAM is located. It is located to know the location of the data. Okay. Any other answers? To identify which RAM it is located, to know the location of the data. Okay. To specify the slave among many of such slaves. Okay. Location of the data to be written. Slave address. Yes. Okay. So there are two purposes actually for this particular address. One is for selecting your slave. Okay. So AHB protocol will support multiple slaves. Okay. So here, if we have more than one slave, so to give the address, so each slave will have different addresses, right? So let's say this is our master, and this is our slave. This is first slave, this is second slave. We will discuss how this particular master is going to communicate with multiple slaves and what is the mechanism here. First, let us simply briefly discuss what is happening. So this, let's say this slave have some address, and this particular slave will have some more address. Okay. So the slave will have some specific address, and this slave will have some specific address. So first the master will issue the address, right? So the master will issue the address in which, using which signal it is going to use this particular HADDR. Using this address bus, the master is going to provide the address, so that there will be some logic, there will be some decoder logic which will decode the address, and it will select the slave. Okay. In middle there will be some another logic which is working to select which slave it should select according to the address which is being given by the H address by the master. Okay, that we will discuss. So the master, what it will do initially, it will give the address. Okay, this address, it is used to select which slave the master wants to communicate. Okay, and one more thing, for every transaction, let's say this master and this slave are communicating with each other. Okay, so there are two lines which we have discussed. One is HW data bus and another is HADDR data bus. Okay. So for every data packet which we are sending, for every data packet which we are sending, the size, the width of the data packet will be of 32 bits or 64 bits or 8 bits, something something. Okay, that we will discuss. What is the width of this data packet? Okay, for each and every data packet, there will be a unique address. There will be unique address associated. Unique address associated. So let's say if the master is sending the first data packet, it cannot send it alone. It should be binded with some address. And if it is sending the second data packet, it is not sent alone. It has some particular address. Okay, so the data packets which are being sent in the HW data bus, these data packets will have a corresponding address. Along with this particular data packets, the address is also sent. Is this clear for everyone? So first purpose is to select your slave address, and second purpose is to associate your data packets with some specific address. Is this clear? Yes or no? Please let me know. Is it clear for everyone? Yes or no? Yes. Is there any doubt here? Are we good? Yes. Okay. No. Yes. So this is what the use of this particular address, and it is of 32 bits width. And next, coming to one more signal which is known as H write. One more signal which is known as H write. Already we have discussed this. So this H write is also output to your master, and this is of 1 bit width. So it can be of either 0 or it can be of either 1. So if this H write is equal to 0, then it is a read operation. And if H write is equal to 1, then it is a write operation. That is, the master is going to use this particular signal H write to indicate which type of transfer it is going to perform. that is whether the master is going to perform the read transfer or the master is going to perform the write transfer. So that this signal, if you see carefully, this is output to your master and this is input to your slave and this is input to your slave. So the slave receive this particular h rate signal and it will come to know whether the master needs a write transaction or whether the master is expecting a read transaction. So accordingly the slave will respond. Is this clear? The h rate, is it clear? Yes. Yes. Now, coming to one more signal which is known as h size, and the width of this particular h size is 3 bits. So this particular h size is also output to your master and it is of 3 bits width, and this is output to the master and the input to the slave. So what is this h size indicates? Now, let's again see your master and again consider your slave. So the master is performing, let's say it is performing the write operation, that is h write is equal to 1. The master is performing a write operation, that is h write is equal to 1. Now, so in the write operation, the master will send the transaction packets. Okay, so it will send some data packets. Now, how the slave will come to know the width of this particular packet? What is the width of this data packet? How the slave is going to know? It is going to decide the width of this particular packet with the help of this h size signal. So the master is going to use this particular h size signal to indicate the width of this particular data packet, whether it is 8 bit or whether it is 16 bit, 32 bit, 64 bit. It is going to tell the width of this particular packet using the signal which is known as h size, which is of 3 bits. So for 3 bits, how many combinations are there? So for 3 bits, how many combinations are possible? Using 3 bits, how many possible combinations can be possible? Eight combinations. From 00000 to, from 000 to 111, we have different combinations. For example, if h size is equal to 000, then it means the size of the packet is 8 bytes. Similarly, so on, this we will discuss. Okay, just I'm giving a example. Okay, so each and every combination have a unique meaning. Okay, 001 has 16 bytes. That this particular head size is used to indicate the width of the transaction, width of the particular packet. Is this clear? Yes or no? Please let me know. The h size, is it clear? Or anyone has any doubt? The h size, is it clear? Is it clear for everyone, or shall I explain it one more time? How many? First, let us start the course. Right, course hasn't haven't started yet. Right, only 2 days, and day one was just an intro. This is day two. We are discussing about interface signals. Okay, and my agenda is to cover all the topics, not just seeing the things from the top. My idea is to go into the deep. What is what happening? That is what my agenda. Okay. So let's see how many days it will go. Okay. Are we good? Is it clear for everyone? Is it clear for everyone? Yes or no? Please let me know in the chat box. Yes. And what do you guys need? Like, shall we discuss the things only briefly, or shall we discuss the things more clearly? What is what uh, in a deep manner, or shall we discuss what is enough for the uh, purpose of cracking interviews or something? Okay, so that is what I'm planning. We will discuss the course deeply only. I will try to cover the things extra little, and we will try to understand what is what, so that basic foundation, yeah, so that our basic foundation should be strong. Like, we will try to analyze the things, what is happening, what does actually mean. Okay, yes. So for this, it will take more time. It will take around 1 month. Okay, So including the code development, everything, it will take around 1 month. Okay, that is what the time which I am expecting. Okay, around 1 month. Is it okay for everyone? Yes. Now, so that was about your H rate signal. Okay, that was about your H rate signal. Now, coming to one more signal which is known as sorry, that was about your H size signal, and coming to one more signal which is known as H burst signal. Okay, that was about your H size signal, and one more thing is H burst. Okay, we'll see about this particular H burst now. So this is your H burst. Okay, this is of also 3 bits width, and this is output to your master and input to slave. Okay, now, so again we will consider the same example where you have a master and a slave with the H address, HW data, and H size for indicating the size. Okay, now using this particular H data bus which we are using for sending the data from master to slave, we can send it only single packet of data from the master to slave in one transaction. In one transaction, we can send only a single packet of data, or we can send two packets of data, or we can send three packets of data, or we can send four packets of data sequentially, one by one. We can send one packet, two packet, three packet, four packet, like this. So this sending of data one by one sequentially, this particular process is known as burst. This particular process of sending the data packets one by one is known as burst. Okay, so the type of burst, whether it is a single packet, or whether it will consist of four packets, or whether it will consist of eight packets, or whether it will consist of 16 packets, how many packets, it will be decided using this particular signal which is known as H burst. So here also we have three bits, so total eight combinations: 0 0 0 0 to 1 1 1. Okay, so 0 0 0 means it is some, I think it is single increment burst. Okay, single burst. Okay, and so on. We will have INCR 4 burst, RAP 4 burst. Okay, undefined length burst. Okay, this everything different type of burst we have. Okay, that we will discuss in deep when we are discussing about that particular H burst concept. Okay, so for now, just make sure that burst is nothing but group of data which are being sent one by one. That's it. Okay, and how many packets that we are going to send will depend upon the H burst signal. Is this clear for everyone? Yes or no? Shall we move forward? Yes. Now, next is H trans, and HP dot signal we are not going to focus. This is an optional signal and we are not going to discuss this in our workshop. This is an optional signal. After completing entire discussion and code development of this particular protocol, if you want to explore the things more, then you can open the specification document which is already available in the Google. It is an open source document. You can study that HP dot behavior, and if you want to go little bit advanced, and if you want to explore the things more, then you can discuss this hp dot everything. Okay, so this is an optional signal that we are not going to focus upon now. One more signal is H trans. Okay, so the next signal which we are going to discuss is H trans. So this is of 2 bits of width, and this indicates the type of transfer. It indicates the transfer type. So for 2 bits, we have 4 combinations: 0 0 0 1 1 0 1 1. So if it is 0 0, that means the master is in idle, and 0 1, it indicates that master is busy, and 1 0, it is a non sequential transfer, and 1 1, it indicates that it is a sequential transfer. Non-sequential, sequential, we will discuss later. But these two terms, I think you can able to understand what is meant by idle and busy. Yes or no? Idle means the master is indicating the slave that it is idle, that it doesn't want to, that it is ready for the transfer, that it is idle. It is not busy any. Yeah, it is free. okay, that it is not involved in any type of transaction. And coming to busy, it means that master is busy with some other transactions or something. Okay, so to tell the slave whether it is idle or it is busy, it is going to use this particular h trans signal. And coming to non-sequential sequential, we will discuss later on when we are discussing the things. Okay, so that was about your h trans signal. And coming to your another type of signals which is known as H mask lock, also we are not going to discuss in this particular protocol. This is an optional signal that also you can explore after completing this particular protocol. This also you can explore it. Okay, if you want to go some more extent, and if you want to learn, you can explore this. Okay. Next, coming to this HW database, also we have discussed what is this particular HW. Okay, so this was about your interface signals which are associated with your master. So with this help, so these are basically your handshaking signals. These are basically your handshake signals. That is, the master and slave are going to use this particular signals for maintaining the synchronization of data between the master and slave. Okay, so these are the signals which are associated with your master. And in next session, we will discuss the signals which are associated with the slaves. Okay, the same signals which are output to your master are input to your slave. That's it. And there will be some more extra signals if needed, we will see. And after that, we'll start with the how the transaction is happening, how the address is being used, everything we will discuss. Okay, yes, so that's all for this particular session. So if you have any doubts or queries, you can stay and ask me, or else you can leave the session. Okay, how many days the course will continue? Yeah, I was told, right? So it will be for 1 month. What I'm expecting is 1 month. It can finish before 1 month, or it can extend after 1 month also. It depends. It can be finished before the 1 month also, or it can extend up to 1 month also. Okay, yes. So if you have any doubts or queries, you can stay and ask me, or else you can leave the session. Okay, thank you. 1 minute.